Hello everyone. Now we have to discuss another important concept of coupled circuits, that is a dot convention. So why we need this dot convention in coupled circuits? So to determine the relative polarity of induced voltage in the coupled circuit. Why we need this dot convention? To determine the relative polarity of induced voltage in the coupled circuit. Then on what basis we are selecting this dot convention? So based on mutual inductance only we are providing dot convention in the mutual coupled circuits. So first we have to write that point. To determine the relative polarity of induced voltage in the coupled circuit or coil, in the coupled circuit, and the coils are marked with dots like this. Then on what basis we are providing this dot convention? On each coil a dot is placed at the terminals which are instantaneously of the same polarity on the basis of mutual inductance alone. Mutual inductance alone. That's it. This is about the introduction of dot convention. So based on the current direction in the dots we can able to tell whether the mutual inductance is positive or negative. Okay, we are providing a dot convention in the coil. Okay, so if the current direction is, we have to take in. So for the different cases we have to consider the current direction in that particular dots, then we can able to tell the mutual inductance whether it is positive or negative. So for that we have four cases. Before the discussion of that four cases, first I would like to tell a important point, that is when the currents through each of the mutually coupled coils are going away from the dot or towards the dot, then the mutual inductance is positive, otherwise it is negative. Don't worry, I will explain with examples. Just wait for that moment. When the currents through each of the mutually coupled coils are going away from the dot or towards the dot, then the mutual inductance is said to be positive value. Like that, when the currents through the coil is leaving the dot for one coil and entering the other coil. Then when the currents through the coil is leaving from the one dot for one coil and entering the other coil, then the mutual inductance is said to be negative. Now we have to discuss different cases based upon this dot convention. So first, case 1. So in this case 1, for example, here I am considering 2 coils, right? Then here I am providing that dot convention like this, okay, dot convention like this. And what about the currents? This is the current, because these two are connected in series, same value of current through these coils, right? Let us say this is self inductance of this coil L1 L2, and we have mutual inductance like that, right? Now we have to tell whether it is positive M or negative M. That's it. What is the statement? When the current through these dots is entering from the both the coils, then it's said to be positive value of M, otherwise it is negative. So we can say in both the coils, current enters from dot, right? So here also the current entering from this dot through this coil, like that the current in the second coil also, the current is entering from this dot only. Then the mutual inductance is said to be positive. Therefore M is nothing but positive, or we can say plus M. So like this we have to represent. Now it is what? Plus, right? This is case 1. Like that we have to discuss case 2. In this case 2 also I am considering 2 coils which are coil, right? So in this I am providing the dot at other end of the coil 1 and beginning end of the coil 2, right? Let us say the coil current is I, the same amount of current I, this is L1, this is L2. The mutual inductance between these two is nothing but what? Or we can say plus M. Like this we have to write, okay? Here we have what? Minus M. Why minus M? See the current direction. In this case, from coil 1 the current leaves from the dot, and from coil 2 the current enters from the dot, right? In coil 1, current leaves from the dot. In coil 2, current enters. Yeah, current enters through dot. Listen carefully, right? So obviously, therefore, then the mutual inductance is said to be negative value, right? Therefore, M which is equals to what? Negative, or we can say negative M. Like this we have to write. Next, case 2. Case 3. In this case 3, now here I am considering from the both the coils the dot is like this. Okay, the dot is like this. Then the current direction is what? I. This is L1, this is L2. Between these two we have what? Mutual inductance. Then it is said to be always plus M. Why plus M between these two? Because in both the coils current leaves from the dot, right? Therefore, mutual inductance is said to be positive value, that is plus M, right? Then last case is what? Case 4. What is that case? So case 2 is what? Leaving, entering. Now it is entering and leaving. Right? Entering, and so we have a dot at entering and at this position. Simply, it is always a negative mutual inductance. Why? From coil 1 the current is entering from dot end. From coil 2 the current leaves from dot end. That's it. This is M. Now we have what? This is minus M between these two. What is the reason here? In coil 1 current enters through dot. In coil 2 current leaves from dot. Then the mutual inductance is said to be negative, right? Now we can represent with negative M. That's it. So these are 4 cases, 4 important cases to represent mutual inductance between 2 coils, right? Now we have to consider some examples. Let us take example 1. In this, I have a coil like this, and like that. This is example 1. Okay, in this, before that, first I would like to draw all examples. Example 2, that's it. Example 3, example 4. Then here I am providing the current direction now through this coil 1. This is downward, this is I1, I2. So from this case 2, here I am considering downward direction, it is upward direction, clear. From this case 3, always I2. From this case 4 also, current is always downwards. Let us say this is upwards, right? Only I have been changes the current direction of I2 only. Then what about the dot convention? Now here I am providing the dot convention from this at this position in case 1, like that. For example 2, 1 is here, from coil 1 here, from coil 2 here. From this coil 3, same. From this coil 4, let us say this, or you can choose any point, okay, or you can change the current direction of I1, then do your analysis. Okay, now like that, this is the L1, L2. First we don't bother about L1, L2, no problem. That's it. Then what about mutual inductance? So from case 1, the current enters from dot, and from coil 2 also the current enters from dot. Therefore we have what? Between these two we have what? Or you can say here, like this we have to write. So from case 2, the current from coil 1, the current enters from dot, like that. From coil 2, the current enters from dot only, then it is said to be plus M. See the current direction and the dot convention. See, from this point the current enters from the dot. Here also from coil 1 the current enters from the dot. Therefore we can say that the mutual inductance is positive. From 1 and 2, simply this is what? Plus M. That's it. Okay, like that. From this example 3, from coil 1 the current enters from dot 1, like that. In coil 2 the current leaves, then it is said to be minus M, right? Now from the 4th example, the current leaves from the coil 1, like that. In case 2, the current enters from, the current enters to the dot. This is what? Minus M. So like this we have to take. Okay, we can write one important point. See, from this example, why it is taken as positive M means that the windings of the coil are wound in same manner from one another. That's why if you consider this and this, you will have positive value of M, because the current is entering from that, okay, from the starting of the winding, because we are providing the dot convention in the starting itself. That's why from the both the coils the current enters from the dot. But coming to this third and fourth example, here the coil 1 always the current enters from the dot, but coming to coil 2 it is leaving from third and fourth. Obviously it is negative value. So now we can write one important point. Physically, less M means that the windings of the coil are wound in same manner from one another. Like that, minus M means that the windings of the coils are wound in reverse way from one another. That's it. See, from case 1 and case 2, see the current direction, and you have to see the current direction as well as the dot convention, whether it is present in the starting itself or ending. Just you have to observe that dot convention, okay, whether it is initial or ending point of that coil. See, case 1, both the dot conventions at the starting of the coils, but coming to case 2, from coil 1 the dot convention is placed at the end of the coil, but coming to coil 1 it is provided at the initial stage. But coming to case 3, from coil 1 it is provided at the end of the coil. Like that also in case of this coil 2 it is provided at the end of the coil. Clear? Coming to case 4, it is from initial point, from coil 2 it is from ending point. That's it. So based upon the current direction, when it is entering through the dot, the same convention is applicable for coil also, then it is said to be positive M, otherwise negative M. Okay, this is about the concept of dot convention.